uh, okay. After the session, could you please share these recordings with the Ebom and Ravish as well, or with me? We will provide you the email address. Okay. Prashant?
Yesterday I had dropped the mail also.
Okay, yeah, thank you. Okay, I hope it's visible to you. Okay, so in TCP, we have the first field, okay, the source port. So we are already aware, like this is the addressing scheme that we use at a transport layer, the source port and destination ports. You guys are already aware what are the ports. Okay, so the source ports, whenever we send the traffic, okay, or initiate the traffic, so in most of the conditions, the source port is a random number. Okay, so the range is from 0 to 65,535. Why? Because if you see, the header size is 32-bit or 4 byte. Okay, so it means the complete header, it is not the complete header size. Okay, this is the one column size that we have. Okay, so that is 4 byte. Then this is also 4 byte, this is 4 byte, this is 4 byte, this is 4 byte. So if you will calculate them, then it will be the size of our packet. Okay, so this one field, it is 2 bytes or 16 bits. So if you will calculate it, the maximum would be 0, or the range will be 0 to 65,035. Okay. Okay, now the next one is sequence number. So, you know, like TCP gives you the guarantee, okay, that I'll transfer your, deliver your packet, whatever you have sent. Okay, so for that, we need a sequencing mechanism so that we can, or the TCP can track like how many packets I have sent and how many are yet to go. Okay, like yet to go, like it depends on how many traffic that we are forwarding, but how much traffic that we have sent so far. Okay, so that is the sequence number. So the sequence number, like it is like how many bytes we have sent. Okay, so you see it is a 32-bit, so very long range. Okay, so even I do not know like the exact number, but it is 32-bit of address. Okay, so the sequence number will be very long. If you will see like 65,000 is the 1600, but if you will keep on multiplying it, then it will be very long range. Okay, but it is just to track the bytes. Okay, how many bytes we have sent so far. Then the next one is acknowledgement number. So whatever bytes that we have sent, okay, on TCP always acknowledge. Okay, suppose you have sent some packet from source to destination. Okay, so you are forwarding the packets. So the source is acknowledging you. Like suppose you send, you have 10 packets, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you have sent 5 packets, okay, from here. Then you send 8 packets here, but so far you have received acknowledgement of 5 packets. That means that like what it says to sender, that the destination has only received 5 packets so far. Okay, then there are TCP timers and some other things. Okay, we will not go that deep, But acknowledgement means the destination or receiver is acknowledging that much of bytes or traffic I have received or packets I have received so far. So after that, like once the 7, 8, 9 packets are received on destination, then it will send the acknowledgement of 8. Okay, although like these days we like when TCP, when they invented that TCP, so they were doing one-to-one acknowledgement, like first packet received, okay, acknowledgement of the first, then second, then third. Okay, but they evolved it by the time. Okay, now they do the selective acknowledgement. Okay, like you received 5 packets, okay, I'll give you one acknowledgement of 5. It means I have received from 1 to 5. Okay, so this is the acknowledgement. So whatever packet or bytes I have received, the receiver sends an acknowledgement. Hey, I have received that much of data. So far, so good. Okay, then the next thing, the like data offset. We will not check this. The most important things here are these flags. So can you tell me like what is SYN flag, Prasad or Ebon?
We're talking about
Finish the final flag.
Sorry, SYN, the first one. I'm just asking about SYN. What is SYN?
SYN, right?
Yeah, SYN flag.
SYN flag is the initial three-way handshake. Used to initiate the sequence number.
Good. Okay, and about FIN?
Is a finish, I believe.
Yeah, this is finish. Then reset RST.
If the connection miss, you have to reset it, something like that. Or if the connection has the error, I believe.
Yeah.
But
yeah, push.
Push is to tell that the data can be translated or transmitted immediately.
Okay.
Push it.
Okay, any difference between push and urgent?
And push urgent mean stand for priority. I don't know what time they use it for. For instance, if you want a data to have a priority over any other data, you can use that one. I believe so.
Push will be used when there is any data dropped in the middle and it's an urgent. The main means the priority to send to avoid any issues.
Okay, and what is this urgent pointer?
Urgent pointer. At the same time,
Okay, yeah, I'll tell you what it is and how they are related to each other. Okay, and also it's good like you guys have an idea about these flags. Okay, so let's start with the SYN. So as we know, like whenever we initiate or any protocol or any application is using TCP, so we do the three-way handshake first. Okay, so we have 3 flags. Okay, like the flags. So first thing, to initiate a connection. So this is the source and this is the destination. So we send a SYN flag. Okay, we send a TCP packet and we set the SYN bit as in 1 and all other will be 0. Okay, so when the receiver will receive, it will it will check, oh, this packet is the SYN bit is set. That means this is the new connection request that I am receiving. Okay, Then because the TCP connection that we create, it's a both-way communication. So why we call it handshake? Suppose like I'm doing handshake with Ebon, okay? So I'll just offer my hand, hey Ebon, how are you? So until unless he like handshake with me, like we cannot say like it's a handshake, okay? So the sender has initiated, offer his hand like for the handshake, but until unless the destination it doesn't offer, okay, that your handshake will not be completed. And also whenever you are creating a connection, so the traffic, the exchange of traffic, it can be on both direction, okay? So we need a both way communication happens. So how it happens? So the destination, what it will do, it will respond back with same SYN bit. So this is this, not this SYN bit, okay, that we sent, that the sender sent. This is the SYN or initiation of that communication from the destination to source. Plus, it will send an acknowledgement. So this acknowledgement is related to this SYN. Okay, that sender has sent me a SYN, and the destination responded back with an acknowledgement, and along with that it is also sending its own SYN. Okay, then this sender, it will send another packet with acknowledgement. And what is this acknowledgement? This is the acknowledgement of this SYN. Okay, that's why we call it three-way handshake, because in the first packet it sent a SYN. In the second packet, what it did, like it is doing both the work. It is sending its own SYN, plus it is acknowledging the first packet or the sender's SYN. So it sent, until unless you do not acknowledge, your handshake will not be completed. So that this sender is saying, hey, I have received your SYN, and here is the acknowledgement. Okay, so we send 3 packets. That's why we call it three-way handshake. Okay. And bare minimum, we need 3 packets for the handshake, okay, to exchange our packets. That's why we call it TCP three-way handshake.
Yep.
Okay. Yeah. So are you, I believe you are good with this SYN and acknowledgement. Okay. SYN is to initiate a connection. Okay. Acknowledgement is the acknowledgement of the packet. Okay. That I have received that packet. Okay. Then the next one, I would say fin. Suppose you want to finish your communication. So your handshake is already completed, okay? And like you started exchanging your data, like sender sent some data and like also received some data, and the communication is done from one end. Suppose sender is done with sending the data, but it is still downloading some data from the destination. So if I'm done with sending the data, what I will do, I will send a fin. Okay. So this fin means, hey, I'm done with communication. So the door or the socket, okay, that is open to send my data, please close it. Okay. So once the destination will receive, it will send an acknowledgement. Yes, I have received your fin. Okay, and your one side of communication is closed. Okay, the socket that we have opened from source to destination, it is now closed, but it can still keep on sending the data from destination to source. Okay, because their communication is not terminated yet. So once the communication from the destination, like destination is done with sending all the data, what it will do, it will send a fin. Okay, then the source will send an acknowledgement. Hey, I have received your fin, and this is the acknowledgement, and we are terminating our session. So you would have heard the 4-way handshake in TCP. Have you heard of it? 3-way handshake as well as 4-way handshake. Ebon, Prasad, have you ever heard of
Yes,
the
I
four-way
got it.
handshake? Okay.
Yes, yes.
Okay, so what it is, now you guys would have got an idea. So whenever we initiate a connection, it is three-way handshake because we only need 3 packets to exchange. Okay,
Mhm.
but when we are doing the termination, okay, the packet can go up to 4 packets. Okay, like the destination sent the fin, then it only sent an acknowledgement. Okay, after that, once it is done, one moment. Okay, let me just use it. Okay, we use it in wrong direction, so it will be this way. Oh, that is different. Hey, sorry guys, I got confused. So this is the first pin that was sent. Okay, this is the acknowledgement of that thing. Okay, 2 packets, then 3 packets. The destination sent its own pin, and then it send an acknowledgement. So it can go up to 4 packets. So the termination can happen up to 4 packets. Okay, the four-way handshake we call it. If someone asks you a question, hey, what do you know? Are you aware of, or what is the four-way handshake in TCP? So whenever we do the graceful termination in TCP, so we can have the four-way handshake. Also, it is not mandatory that you exchange the 4 packet. Suppose, so you send a fin, okay, the sender, source to destination, and the destination is also done with sending the data. So it can send acknowledgement of that fin plus it can send its own fin as well. Okay, so you are receiving fin and acknowledgement in the same packet, and then it only needs to send an acknowledgement. So within just 3 packets, your connection can be terminated. Okay.
Okay.
So there can be so many ifs and buts over there. Okay. But you need to understand what the fin flag is to use when we gracefully terminate our session. Okay. So that is to finish. Now, any doubt and send fin and acknowledgement so far?
No. I believe I learned this a long time ago. I cannot recall. We used to call something like that, like tear down. I don't know if that relates to what you just say. When the communication is tear down.
Okay, tear down.
Yes.
Yeah, the tear down means like you are terminating the session. Okay.
Yes.
So like different people are even even in some books or on articles, you will see different terms. Okay.
Yes.
So tear down or closing a connection, these are synonyms to each other.
Yes.
Okay. So now send fin and our acknowledgement is done. Then the reset. So reset means whenever you want to terminate the session, you just send a reset and your session will be terminated. You do not need any other packets.
Okay.
Okay. So like it happens, in some scenarios, suppose your application, you are accessing something. Okay. And the destination server got high utilized. Okay. And like it has got some another priority connections, and your connection that that is there, that is less priority one. Okay. And like they want to terminate your session even without the complete communication, like you are not done with downloading or uploading the data, and they want to terminate your session, they just send a reset bit and your session will be terminated. Okay, so at any moment, if the sessions needs to be terminated by any of the parties, source or destination, suppose sometimes what we do, we start downloading anything. Okay, suppose we are downloading any movie, and like then like you recall, hey, I have already downloaded that one. Okay, let me cancel it. Then you just click on cancel. Okay, then you can terminate your session at any point of time. Okay, that is reset. That means you are not doing a graceful termination of TCP, like either of the party is not like they are not done with the transmission of the traffic. Okay, so In that scenario, we can use the reset to terminate the session at any moment. Okay, you do not need any acknowledgement for reset. Just send a reset, your session will be terminated. Okay. Got it?
Yes.
Okay. So now the only two we are left. Let's go with the push. So as you guys know, the default MTU, okay, that we use for Ethernet, that is 1500. Okay, that means the 1500 bytes of traffic we can send at one. So it excludes our TCP header and the IP header. Okay, it includes that one. Okay, so like 20 bytes and 20 bytes. Then our MS. Okay, let me just explain one thing before we just go with this. What is MTU and what is MSS?
MTU is there's minimum transport something. MTU is the volume that the datagram can send in the internal link.
And MSS?
MSS, I don't know that one.
Okay. So yeah, you said MTU is a maximum transmission unit. Okay, the data that we can set at one. Okay, and we use this term at layer 3. Okay. So what MTU includes and what is MSS? MSS is maximum segment size at the transport layer. Okay. So MTU is, suppose MTU is your IP header. Okay. Plus your TCP or UDP, like it can be like we are using TCP, but it can be UDP header. Okay, because UDP header plus your data, or we can call it MSS.
Okay.
Okay, so now you understood what is MSS. Like if you exclude the IP header plus TCP header size, the remaining part is the maximum segment size. Okay, so suppose this is our transport layer. Okay, this is our data or like IP layer, network layer, and this is our Ethernet in a data link layer. So at transport layer we have MSS. So MSS is because whenever we send any data, okay, from any layer, it adds its header and then the data. So suppose at layer 7 you are forwarding an HTTP packet. Okay, so what it will include? HTTP header plus data.
Okay.
Okay, when the packet comes down to our transport layer, it will add TCP header.
Yes.
Okay, plus your HTTP header plus data will become data for this. Okay, and this is the header.
Okay.
They will become data. Then if it will further go down, so it will add IP header. Okay, and the data part of IP header would be TCP header plus like HTTP header plus data. Okay, so this is how the traffic flows. Like at the top we have HTTP header and the data, okay, that is requested. When it comes to TCP or network or our transport layer, the HTTP header plus data, it becomes the data of the transport layer. Okay, then transport layer adds its own header. Okay, suppose we are using TCP, so it will add TCP and this will be the data part. Okay, when it will go further down, then this complete thing, okay, it will become data of our IP layer. Okay, this is how it works.
Okay.
Got it? So this HTTP or whatever we are receiving from the layer 7, it is our MSS. Okay, maximum segment size. Okay, and what is MTU? Okay, so at transport layer, we use this term, maximum segment size. Okay, and at network layer, we use MTU. Okay, maximum transmission unit. So what it includes? It includes the IP header plus TCP header plus our data or MSS, you can call it. Okay. Any doubt, any question, Abom and Prasad, between MTU and MSS?
No, it's clear.
Okay. Only mark. Okay. So now let's start with something. Okay, we are going to cover our push flag. So what is push? So there is a bus, okay, and it has 20 seats or 15 seats. So the driver, it cannot, move the bus unless the 15 people sits on each and every seat. Okay. So it will wait at bus stand and people are coming, and once all seats are full, then it will take its bus to the destination. Okay, then it will start its bus. After that, the next bus will come at the stand. Okay, the number of seats are 15. So what it will do, it will wait unless all the seats are full. Okay, then the seats are full, then it will go further than the next bus will. Okay, this is how, in our real world scenario, the things work. Like if you would have, I'm not sure about like the same scenario is in US or not, but in India, we have seen it like in tempo and bus until it fills up, like you cannot depart your bus. Okay, so this is the normal scenario. So this is the same scenario when it comes to packet transfer. Okay, so your maximum segment size, okay, MSS. So suppose its size is 1460. Okay, because our MSS, okay, our MTU is 1500 bytes. So what we exclude 20 bytes of IP header plus 20 bytes of TCP header. So if you exclude these 40, that means 1460 will be the MSS. Okay, yeah.
Rishi, can you please start from 5 minutes backline because I missed everything due to internet issue.
Sorry?
I had missed the class for 5 minutes, last 5 minutes due to internet issue. Can you repeat it again?
Okay. So where we were, like, did I explain this bus scenario?
First starting, from bus scenario starting onwards.
Okay. Let me just explain it again. So the normal scenario, Prasad, if you have heard, like a bus at a bus stop, like we got a bus, okay, and it has 15 number of seats. So unless all the seats fills up, then the driver will move it towards the destination. Then the next bus will come. It also has 15 seats. So unless all are fills up, then the bus will depart towards our destination. Okay, so they will wait unless all the seats are full, okay, or filled, then they will move the bus. Okay, so this is the normal scenario that that happens like in real world scenario. But when it comes to the packets, it works the same way. Suppose this is our maximum segment size, okay, that is 1416, because if our MTU is 1500, so if we want to calculate the MSS, so we need to remove the header size of IP and our TCP. Okay, So the minimum size for IP and TCP is 20 bytes. So if we exclude 40 bytes, that means this is our MSS. So what happens, like in the buffer of the system, like it waits until unless I receive 1460 bytes. Once the 1460 bytes are received, so it will create a packet and it will forward it towards the destination. Then again, the buffers will wait. Okay, the 1460 bytes are received. Okay, it will create a packet and it will forward to the destination. Okay, but in some scenario, what if like you will not receive the 1416 bytes? Okay, and like if your buffers will not fill up, or it will not meet the minimum size of the MSS, your packet will not be forwarded. And what are the scenarios? Suppose you open Facebook. Okay, facebook.com. You entered your username and password. So you have very minimum data. Okay, suppose it is only 500 bytes, and you clicked on login or click on sign in, but you do not have any other data. Okay, but the minimum, okay, the rule for this is until unless like it fills up 1416 bytes, okay, the MSS size bytes, then it will not send the packet. So your packet will will be waiting in buffer or waiting for more bytes to come. Once it is completed 1416, then it will forward the packet. So in this scenario, you will never be able to log in into the like in Facebook, or even suppose you are taking telnet or SSH of any router. You just enter your username and credentials, and they use very less bytes, so you will never be able to log in. Okay, so in such scenario, when the application developer, they develop the application, okay, they uses their as per the programming language, the function varies. They uses something to push. Okay, push means it really doesn't matter that the minimum segment size or the maximum segment size traffic or bytes are received or not. As soon as we will see the push flag is set, that means your packet will be delivered to the destination. Got it?
Yeah, clear.
Okay, so you got. So whenever we want to forward any packet at the moment without even filling up or the maximum segment size, the MSS size packet, if we want to send it right away, we set the push flag and the packet will be forwarded just right away. Okay, so this is where we use the push flag, and the best example is when we log into any device. Okay, we only enter the username and password and just hit enter, or click on sign in, and we just want to forward that data immediately. So in this scenario, we use push flag. Okay, this is the one. There are some other scenarios as well. Any doubt on push flag?
No.
Okay, great. Now let's come to the last one, that is urgent. Okay, what is urgent? Suppose you have a like a plane. Okay, I'm not very good with the drawing. Okay, so like here you have business class. Okay, and here you have economic class. So like you the aviation department, okay, they receive a notification. There are 10 VVIPs are coming. Okay, and we want you to arrange the business class for them. Okay, and also the front seats in business class. You cannot let them sit anywhere else. Okay, they will be sitting in front, like from in the first like I believe 5 seats. Okay, so but in the current plane, what is happening, like the first 2 seats are already occupied by someone else. So, and they are not ready to vacate them. So what they will do, okay, the VVIP, they will be, like, okay, like they will say, sir, please wait into the waiting room. Okay, we will arrange it into the next flight. Okay, so in the next flight, they will book the front seats. Okay, as requested, and you will be, like the plane can depart from towards the destination. So in the urgent data, sometimes we have urgent data. So we want to, although like it is urgent, but it is not something to forward immediately. Okay, you are marking it as an urgent, but it is not something, it can delay. Okay, you do not need immediately, but this is something very important data. So how the systems, or like suppose you are forwarding from one place to another, from one system to another, so how the destination or receiver will identify, hey, how much data is urgent? Okay, because you have 1460 bytes of MSS, and suppose the urgent data is only 1000 bytes. Okay, so it's not that you will like one thing what you can do, you can set urgent flag and then you can add push flag. Okay, so when the receiver will receive it, they will say, oh, this is urgent and this is push. Okay, so like the destination can consider it as an urgent. But the another thing, like this is how it doesn't work in real world scenario. Like how it works is, it will always, if any data is marked as an urgent or important data, so the urgent flag will be set for that one. Okay, and till when the data ends, suppose in the packet, it will always put at first. So suppose you already have a packet. Okay, you already filled up with 400 bytes. Okay, and the urgent data is like 1000 bytes. So you can add that data here, but no, in urgent, it doesn't work that way. They will keep that data in buffer. Okay, and when this packet will be sent, and the next new packet, what it will do, it will put that data at first position. Okay, and the size of this particular data is 1000 bytes. That means where it is ending from year 0 to 9999. Okay, and that 999 will be put here in this urgent pointer. Do you see there is one more field in TCP urgent pointer? So wherever your data ends in the packet, it will point that particular pointer. So the pointer will be 999 here. So when the receiver will receive that packet, it will check urgent flag is set. That means the data in this particular packet from 0 position or the first position, we have urgent data. And where that data is ending, it will check this field, urgent pointer. Okay, it is ending at 999. Okay, so this is how the destination or receiver identifies the urgent data. Got it?
Okay. Okay.
So the urgent flag and urgent pointer are interrelated. So the first condition with the urgent data is it will always be put at the front in the new packet. Okay, and wherever it ends, the pointer will be mentioned. Okay, the sender will mention that pointer. So when the receiver will receive, it will mark this data from 0 to the pointer, whatever we have, as an urgent, and it will treat it accordingly as per the application. Okay, whatever way the application wants to handle it.
Okay.
Got it?
Okay.
Any doubt or any question, query?
What moment do we use urgent data? Do you have any example?
Yeah, it depends on applications. Okay, so suppose you have some application, okay, and they want to mark some data as in urgent. Okay, and important data. So it cannot be urgent, it cannot be, might be something important data, okay, that the application want to handle.
Okay.
So they want the, you know, the application medium to handle this data, okay, carefully, and also inform to the destination, hey, this part is urgent or very important, okay, please, you know, treat it differently. So this is the same thing, okay. Suppose someone is you know, visiting your place, okay, and like if someone or your, you know, wife's brother is coming, okay, that is the most important person in the world, okay. So like he's visiting and your wife says, hey, my brother is coming, okay, please, you know, take care of him and give him a special treatment. So what you will do, you know, okay, that this person is coming, you will give him a special treatment, okay. But like, well, your you know, one of friend, old friend is coming, okay, although like he's very good, but friends are, you know, like we have informal relationship with our friends, okay, we do not do formality with them. So you know, your wife's brother is coming, okay, you have to, and you know, treat him very well. So this is how some applications, okay, they, you know, they are designed in, although like I do not have any examples, so you know, like where the which application uses this, okay, but this is how the source, you know, informs to the destination, hey, this is the urgent part, please handle it care. Might be in that application like that, you know, to handle that type of data, okay, they have different functions or programs, okay. So they will receiver will receive it and it will forward that data to the application, hey, this is the urgent data, okay, you need to handle it you know, the way you are configured for it. So this is how they handle the data, okay. And this is just a medium of our TCP to inform, okay. Yes, we have a feature, we can, you know, inform to our destination that this is very important data. Or even sometimes whenever we forward something, we mention on our package, handle with care, okay.
Okay.
If we have any glass or something, you know, any, like we are forwarding something that needs to be, you know, handled very carefully, otherwise it will break or something. So we mention that handle with care on our parcel. So the same way you can mention in the packet, please handle with care, okay. This is very important.
Yep,
okay.
yep, I got it. Yep.
Yeah.
Makes sense.
Yeah. Prasad, any question, any doubt? Hello, Prasad, you there or you got disconnected? Hello, Prasad. Everyone, I believe I'm audible. Hey, Prasad, are you there?
Maybe he mute.
Okay, okay. Yeah, he's on mute. Yeah, that's fine. Okay, so the checksum we already know. Okay, like we just okay. I will not go you how to calculate the checksum. Okay, so checksum will be calculated. So when the, you know, receiver will receive the packet. Okay, when the sender sends a packet, it calculates a hash value. Okay, and it just, you know, use the data and it you know, perform a checksum and it put that hash value in this checksum field. So when the receiver will receive the data, it will calculate the checksum, okay, for the same packet and it matches with it. If it is same, that means the data or the packet was not altered, okay. So it is same thing. Suppose you are sending me, how are you, okay, and you want me to, like, how you are performing the hashing. Suppose the hashing result for this will be 1, suppose 100, and like someone, you know, took the packet capture, okay, they altered it, okay, and once it is altered, then your checksum will be changed, okay. Even one letter will change, your checksum result will change, okay. And even suppose your packet got you know, some of the part you know, it got dropped like during the transmission. So when the destination will calculate it, the checksum will be different. So this is how the source and destination defines like the packet is altered or not in between, okay, or some part of the data got truncated or not. Okay.
Okay.
So this is, suppose you are forwarding a parcel, okay, and its weight is 1 kg and 100 gram. Okay. So you forward it to the destination and you call to your friend, hey, the size of this, okay, or the weight of this parcel was 1 kg, 100 gram. Okay, please, check it at the when you receive it. So someone in between, he, like there are few things, okay, that is, they are in parcels. Someone opened that packet and suppose you are sending 5 iPhones, okay, and someone took 1 iPhone. Okay, and then he just closed the parcel again and forwarded to destination. So the first thing that your friend will check before opening it, because suppose your friend has opened it, okay, and after that he will call you, hey, I find only 4 phones in that. Then you will say, hey, I sent 5. Okay, might be you are telling me that you only received 4 and you are hiding 1 phone from me. Okay, so before he will open that or open that package, what he will do, he will wait. Okay, and if the weight is equals to 1, like with this, that means the packet was not altered in between, or someone, nobody stole something, anything from this packet. But if it is 900 gram, it means he will call you, hey, the weight of this parcel is 900 gram. So like, what was the weight when you when you waited before sending? You will say, hey, 1.100. Then he can say, hey, I'm not opening this, okay, and this, he can click the photo and he can send you, hey, this is how it is. So might be someone, or it was altered in between, someone like open that packet and install something from this. Okay, so this is the same way the checksum is calculated of the packet, and that value is they put it here. So when the receiver receives the packet, it just checks this, it calculates the checksum again, and it compare it with this checksum. If the value is same, that means the packet you have received, or the receiver received the packet the way it was sent. Okay, there was no truncation. So that is the checksum. Okay, so there are some mathematical calculation that happens in background. You do not need to worry. So we have systems, and like they can do it, or they do it by themselves. Okay.
Okay.
So okay, now the next thing, okay, how will sales impact customers? Okay, windowing. Okay, so what is windowing? So okay, let me just windowing. Suppose you have a source, and here is the destination. So the destination can receive 500 MB data at one go. Okay, and the sender can send 1 gig data at once. Suppose its buffer size, the RAM and memory is very high. It has 32 gigs of RAM. It only has 24 gig, or suppose 16 gig of RAM. Okay, so the buffers that the receiver has, so it is only 16 gig, or like it can only receive 500 MB of data at one go. But the sender can send 1 gig. So suppose he's sending like your data, and you can only have like store 500 of MB data, and so there will be a flow control. Have you heard of flow control in TCP?
Yeah.
Yeah. So suppose you in your house, you can only place, like you have a room. Okay, in that room someone sends you a bed. Okay, so your size, room size is 6 by 10 by 6. Okay, so you receive a bed, and the size of the bed is 8 by 6. Okay, so you can only keep one bed in this room, okay, with this size. Otherwise, you know how much is left? 2 by only 2 feet are left in your room. So you cannot, you know, fit any the next bed in your room.
That's
Okay.
true.
Yeah. So the same way, if the destination can only receive 500 MB of data at one go, then you cannot, might be your forwarding speed or your buffers or your, you know, transmission speed or the capacity of yours is very high, but the receiver cannot hold that much of data at one go. Okay, so in the scenario, our TCP provides the flow controls. Okay, so when the TCP handshake happens, it also exchanges the window size. Okay, so if you see the window size is 16 bit of field, so it can be maximum 65,535. Okay, so suppose what it will do, it will send 1 gig. Okay, hey, I can send you 1 gig, or suppose I can send you 65,555, but I can only handle 30,000. Okay, so the window size that is selected during the TCP handshake is the receiver window. Okay, so how much I can hold. So suppose the receiver can only receive 30,000 bytes. So what it will do in the send, the sender like the sender will send, hey, I can support 55,535. But the receiver say, hey, I can only hold 30,000 of bytes at one go. So what it will do, it will send 30,000. So the window that will be agreed will be the lesser one. Okay, and it can happen in this way. The sender can only send this way. Okay, but receiver can hold 65,535. So in this scenario, the minimum window that we have, okay, it will be agreed. Okay.
Okay.
And also this window size, it varies. So what it means, the window size means like how much packet the sender can send without acknowledgement. Okay, so suppose it is 65,500 and this is 30K. So the sender can send 30,000 bytes without receiving any acknowledgement. Okay, so suppose you send 30,000 bytes, okay, and after that you received an acknowledgement of 20,000. It means now the 20,000 bytes, like the receiver, it only has 10,000 bytes, and now I can send more 20,000. Okay, because the current capacity is 30,000. Okay, the maximum. So we receive acknowledgement of 20,000. Along with that, you know, within each and every packet, the destination, it sends its window size. Okay, I'm sending you acknowledgement of 20 bytes. Okay, now I have 20K window. So it means, so you receive 20,000. Okay, then it will, you know, keep on sending the acknowledgement. Okay, because what happens whenever you receive such data, you received it and it will keep on sending to the application. So application, once application receive the data, okay, we can remove it from our buffers. Okay, we have a buffers, so we can remove from our buffer. Suppose you are doing any business. Okay, so your businesses, you will rent the homes, okay, to the people. So you have a warehouse, and that warehouse can keep you know, like 100 boxes. Okay, 100 box. So what you mean, like you received 100 box, that means your warehouse is full. So you will say to the, you know, the parcel from where you are receiving, hey, I'm already full, please hold for some time. I cannot keep you know, more boxes in my warehouse. Okay, I do not have place. So what you will do, you will ask your delivery guys to, you know, start delivering the boxes, okay, wherever they are supposed to go. So once you send, then suppose they already delivered like 60 boxes. So now you have 60 box place. Okay, So what you can say, you can call to your, your partner, or the person who is dispatching the box. Hey, you can send me 60 more. Okay, now I have some 60 place vacate at my place, in my warehouse. So they will send 60 more. So now it is again 100. But after that, suppose they delivered 90. Okay, so you only have 10 boxes. That means you have 90 places available. So what you will do, you will call them, hey, please send me 90 more. So they will send you 90 more. Okay.
Okay.
So this is how the window size works. Okay, it varies. So as soon as like from your buffer, the packet will be forwarded to the application. Then the TCP will send you a response. Hey, I have received that much of traffic. Okay, and now my window size is 15,000. It means now the sender can send it 15,000. So it happens, dynamically. It is not that you only agreed 30,000 and your window will always be 30,000. So the same way in your warehouse, it depends how much packets you have. So the same thing in the TCP, how much packets that you have forwarded to the application, and then you need to acknowledge it to the source. Hey, now I have that much of buffer available. You can send me that much of data. Understood?
Yeah.
So the window size, it varies dynamically.
Okay.
Okay. And also, like, because as per the TCP, we can, it is a 16-bit of field. So it's 65,535. Okay. The maximum can be. But these days, like, we have high-speed internet, and even systems are very, like, they are very, they work at very high speed. So our window, okay, or the buffer size of the destination can be very high, but we cannot have the more than this, okay, because this is the limitation of our header. So what they have TCP option. Okay, the option is scaling factor, because here they cannot modify anything in the header, but in the optional field they added scaling factor. So what scaling factor does, suppose you added 2 scaling factor, it means 2 to the power 2 equals to 4. So if this value is 4, it means I have a window size of this multiply by 4. Okay. And if it is 3, scaling factor is 3, that means 2 to the power 3 equals to 8. So what is the window size? Whatever size that is there in this field, just multiply it with the 8. Okay. About understood the scaling factor?
Yes, I got it. I was yeah. I never understand the option. That's option, but it makes sense now, because they always say it's optional, but it makes sense to me now.
Yeah. So this is option. So because suppose the thing is that you build your house, okay, and you have backyard. So, and this is your drawing room, this is your bedroom, okay, and this is your washroom, and this is your kitchen, okay. But after that, you want to make one more room. So it's not that you can break this room, okay, and you make 2 small rooms, because it is already 10 by 8. So you can only have one bed. So you cannot break it 5 by 4, 5 by 4. Okay, it won't be useful for you. So what you will do, either you will make a room in your backyard, okay, or you will just add it here, or you will just go build it at first floor.
Okay.
Okay. So the same way, this is the TCP header. Okay, they have already built a house. Okay. So they cannot, if they will, because this is the global standard. Okay, so many applications, vendor devices, they are using this standard. If you will make change over there, then there will be so many, software changes would be required.
Yeah.
So what they did, okay, we are keeping our house as it is. Okay, you are not making any change. Either you will just build at first floor. Okay, So they kept this backyard, okay, the options, okay. This field is there. So if they are, getting new feature and they want to add it, they will get it add here, option. Okay, understood?
Yep, yep.
Yeah, that's it. It's very simple. Okay, now the most important part you need to understand in the TCP header is source port, destination port, and the TCP handshake. Okay, 90% you will be using this, 10% the other things like when you are doing packet captures or something. Okay, you would be required this. Okay, and the MSS. Okay, now you know MSS because what is the part of data transport layer? TCP header plus. So this is MSS. So these are the important things that you need to just remember for TCP. Now let's come to the UDP. UDP we do not need to go there. Okay. Okay, this is UDP header. It is nothing. It has nothing. Source port. Okay. And destination port. We have the same thing in TCP. And the UDP length. Okay. The length of this packet. Okay. And also checksum. Checksum is like it works the same way we have it in TCP. Okay.
In TCP,
it has nothing. Yeah. So UDP, it does not give you guarantee to deliver your parcel. Okay. So if you want to forward something, okay, and it is not urgent, and if it get delivered or not, if you really don't care, then use UDP. Okay.
Yep.
But UDP is also very important. Why? Because with the real time applications, okay, suppose audio calls, okay, we are talking on Zoom, okay, they are using UDP, okay, for the audio call or video call. Why? Because suppose I'm saying you, how are you? A bomb, okay. So if it is UDP, suppose this packet got dropped, okay, then you will receive how you a bomb. Okay, that means you will understand, okay, like the packet got dropped, but it is supposed to drop, because if we will be using TCP here, so what TCP does? TCP does the retransmission. So how TCP will deliver this? How you a bomb are. Okay. So whenever we transmit our audio traffic, suppose we are talking to to each other, and suppose one of the particular portion of the phone call get dropped. Okay. So if it is dropped, that means it is dropped. You can ask me, hey Rishi, what you were saying, I believe you broke up. Okay. And can you repeat it? I can repeat you. Okay, that will be the feasible medium. But what if I'm repeating it, and after that you are again getting whatever the lost, whatever packet we lost, okay, when I'm explaining it to you again.
That's true.
Yeah. So UDP is very important in such scenario. Okay. So yeah, sometimes people say UDP is not good because it does not have any, it does not give you guarantee. But yes, sometimes we have some data that really does not require to destin or to deliver, for guaranteed delivery. So for the real world data, we use UDP. Okay, audio, video calls, and these things, and even live streaming. Suppose you have cameras at your home and you are watching them from office. So you do not want, if something is dropped and you are your videos are getting disturbed, like packet drop, then they are again forwarding. You want the live stream, if something is dropped, that means let it drop.
That's
okay.
True.
Yeah. So in such scenario, we use UDP. Got it?
Yep.
Oh, great. Copy and then paste it. Okay. This is our IP header. Okay. So IP header. So the minimum size of IP header and TCP header is 20 bytes. Okay. You know why 20 bytes? So I explained you one thing when we started. The size of this is like 0 to 32 bits or 4 bytes. Okay.
Okay.
So that 4 bytes means this is the one column 4 bytes. Okay. This, suppose one row is equals to 4 bytes.
Okay.
4 bytes. Then this row again, it will be 4 bytes. Then this row also 4 byte. This row also 4 byte, and this row also 4 byte. And these are the mandatory fields of our TCP header, okay, and the IP header. So if you will calculate them, 4, 4, 4, 4, 4 equals to 20. Okay. These are the mandatory fields. You cannot skip any field from the header. But options can be skipped. Okay. It's not mandatory that you use options or not. Okay. But
Okay.
they has to be there. So that's why we call what is the minimum size of TCP or IP header? 20 bytes. Okay. And for this minimum will be 8 bytes. Okay. For UDP, because it has only 2 rows. So 4, 8 bytes. But in here, 4 bytes, 4 bytes, 8, 12, 16, and 20. So your IP header size cannot be less than 20. If it is, then the receiver will receive it and it will drop your packet. Okay? Because it is not following the internet standard that this minimum size can be 20 bytes and maximum it can go to 60 bytes. So that means 40 bytes options. Okay?
Yep.
40 bytes options. So if you are using options, that is fine. It will increase. If you are not using it, so at least bare minimum will be 20 bytes. Got it?
Yep.
Okay. So let's do first field. Okay, that is version. Okay. So you are using IPv4 or IPv6. Okay. So here it mentions from this part of the packet, you can check it is IPv4 or IPv6 packet. Header length, what is the length of the header? Because here if you see header length, that means the header length. So what is the minimum? 20. You will see 20 here, but if you are using option, then it will be increased. Okay, it can be 30 or 40, whatever it is. Okay. Now these are DS field. Okay, we use them for quality of services. Okay.
Quality of control.
Yeah, quality of services and control, like we call it. So we use them. So like it has some, like first 2 bits are reserved, then we have 6 bits. So first 3 are priority. Okay, so that's how we our class 1 to 1 AF. Okay, 1, 2, and then other classes that we have. Okay, we will not go to check the quality of services, but these are used for QoS. Okay, then the total length. Total length means the header length plus data.
Data.
Yeah. So if someone would say you, hey, can you tell me what is the data length in this packet? Can you calculate it?
Yep, you just add
because you will be having total length. Okay, just header length, you have it here. Remove mine, just subtract the header length from total length, you will get the data length. Okay. Yeah, that's that easy. Identification. This is the common thing. Okay, so let me give you an example for this. Suppose you have a PC. Okay, here you have a firewall. Okay, that you are doing NAT. Okay, for the internet, and you are forwarding it to a destination. So you send a packet, and here you perform NAT. 1 node. So if someone asks you, like you took packet capture here and you took packet capture here, okay, here on this interface after the NAT. So how you can identify the packet before NAT and after NAT? Because once you will do the source NAT here, that means your source IP will be changed. So how will you identify what is the like which packet we perform netting, okay, and after netting, what is that packet if you want to compare both the packets? So their source IP can change, okay, but from source to destination, your identification will remain same. Okay, so even you are doing netting, your identification will not change.
Okay, I got it.
And it is also used in so you got it, like what is identification? That is unique from source to destination. Okay, now the next thing is flags. Okay, so one flag is reserved and these are used for fragmentation. Okay, one is for more fragment and one is do not fragment. So if do not fragment is set, that means this packet cannot be fragmented by any layer 3 device, okay, in between. You cannot fragment this if this do not fragment bit is set, okay? And if more is set, that means the packet got fragmented, okay? And if it is set to 1, that means there are more fragments for this. You know how we use these fragments? Suppose you have a packet. Okay, so its size is suppose 3500 bytes. Okay, and in one packet it is going 1500, then 3000. Okay, and this. So like you forwarded this packet, okay, and this needs to be fragmented at layer 3. So what you did, you added this packet, okay, and also your identification will be same in this. Okay.
Okay.
Your identification will be same on all these 3 packets. Okay. Those you are fragmenting. Okay. And also it will be setting the more bit. Okay. 1, 1, and here it will be 0 when you will receive it destination. Okay. So you will receive the first packet. It will check the fragmentation bit. Oh, it is 1. That means there are more fragment to come. So it will keep that packet in buffer. It will not forward this to the application. So when the second packet will receive, okay, I received it. I will add it here, okay, from this fragmentation offset value. It will check what is the fragmentation bit set. It is 1. That means there is more fragments to come.
More fragment coming.
Yeah. So then it will receive the third fragment and it will add it here. Then it will check the fragmentation bit, or it is 0. That means I do not have more fragments. Now this packet can be transmitted to the application.
Okay.
So this is how these flags use on like IP header. We have only 2 flags. One is do not fragment and one is like more fragments. Okay. TTL. This is time to live. How long your packet can live on the internet. Okay. And when we use it, suppose if we do not have it, so what is the disadvantage? Suppose you have Instagram, okay, and you do not have the routing, okay, destination is not reachable. So your packet first, okay, and they have connectivity, okay, to each other. So your packet will come here, then it will go there, default gateway, then it will take again default gateway, then it will take again default gateway, default gateway, default gateway, default gateway, default gateway. It will keep on traveling over the internet. Okay. It will never die. Okay. Immortal. Okay. It will become immortal packet. So to resolve this problem, they came up with TTL. Okay. So the maximum TTL can be 255. So whenever the packet will, deliver or, delivered from one device to another, the TTL will keep on decreasing. So it will be 255 here, but when it will, this device will send this data, it will decrease it to 54. Here it will receive, then it will be after this 253, then 252. So when it will become 0, then your packet will be dropped automatically. Okay. So that's why we use TTN to resolve that problem.
Yep.
Okay, then protocol. So what protocol says? The above layer protocol. So suppose the above layer means the transport layer. Okay, what data it is carrying. Okay, it is telling what data is there. So we are using, suppose TCP. So you will see the protocol TCP. If it is UDP, then you will see UDP.
Okay.
Okay. And if it is, suppose you are using IPsec, then you will see ESP here. Okay. The protocol number, I believe it is 50 or 51. Okay. For TCP, it will use a different, the protocol, it tells what data I'm carrying. Okay. So it's something like what you are carrying in your truck. So it is mentioned over there. Oh, this is the product that I'm carrying in this. So this is the same thing that we have. Okay.
Are you still there?
Yeah, I'm there. I'm there.
Okay.
Yeah.
Okay.
So you understood the protocol? It tells what I'm carrying. Okay.
Yeah.
Then the header checksum, it calculates the checksum of the header. Okay. Only the header part. Okay.
Only the header part. Okay.
Yes. So it does not calculate the checksum of data. Why? Because at TCP and UDP, they are already calculating the header, data checksum. So you do not need to do it again. Okay. So it will only do the checksum of header. Okay. So the most important thing in the layer 3 is the source IP and destination IP, the addressing scheme that we use. Okay.
Yeah.
I know, like, you are already aware about the source IP and destination, whatever we are sending, and the destinations.
Yep.
Okay.
You keep on moving hop by hop by hop.
Yes, hop by hop. Yes. So now the next is Ethernet. So on Ethernet, just don't confuse yourself. The important fields: source MAC, destination MAC, type, and then your data. What type? It tells what is the next layer protocol I'm using. Suppose it is using IPv4. Okay. So in the type, you will see, hey, I am carrying the IPv4 packet in my data. If it is IPv6, then it will say, hey, I'm carrying IPv6 data. If it is carrying the ARC packet, it will tell, hey, I'm carrying the ARC data. Okay. This is the type field of Ethernet. Okay. About?
I'm taking a note.
Yeah, yeah.
Okay. So because I got it. Now I got it for the Ethernet. Yes. Okay.
Okay. Ethernet, source MAC, destination MAC, type, what I'm carrying. Okay. What data I'm carrying. So if it is IPv4 header, okay, IPv4, it is IPv6, IPv6. If it is ARP, then it has different codes for them. Okay. You can search on Google what is the type code for ARP and other packets. Okay. So this is what it tells. Okay. Yeah, we are done with this. Anything, any question, or if I'm skipping anything, or you want me to explain something so far?
No, it's clear. We will go through once again.
Yeah, great. Okay, so these are the packets. Okay, we are already done, and now, okay, tomorrow I will be covering IP sec and SSL. and also how the certificate authority works. You know, like whenever you type https www.google.com. Okay, so let me just
Okay.
open this one. Okay, so you see it is showing you secure a lock over there. Okay, that means this connection is secure. But how SSL works, okay, how they negotiate the keys, how IPsec negotiate the keys. Okay, I will explain you like in the best way. So if you will click here, okay, you can check it over there. Just click on that lock, then connection is secure. Then the certificate is valid. Just click on it. Here you will see the details. Okay, so here you will see the common name. Okay, this site. Okay, this site is networklessons.com. Okay, who is the who assigned this? Okay, so this is Amazon RSA. Okay, so the organization, that means this certificate is provided by the Amazon. So we have Verizon. Okay, we have DigiCert. Okay, these are the certificate authorities that we have. I will explain you tomorrow. Okay, I just don't want to overburden you, but just go ahead and do some research about how IPsec works and how SSL works. Okay, so when we will connect tomorrow, you guys you would have already understood it. Okay, might be better than me. And also if I'm explaining you, and like we will be having a discussion over there. Okay, you will be having doubts, because when we prepare something, okay, that means we know something about it. If someone is telling to us, hey, I have heard of this, like it works that way, so can you tell me, then we can have a discussion. You can have doubts when you know something about any topics or anything. Okay, so IPsec, SSL, we will be working. Okay, I'm giving you a video. Okay, that will give you the best description. So this guy was my trainer when I was in Palo Alto Tech. Yeah, watch this video.
Okay. Can you send that in the chat?
Yeah, I'm sending it. Yeah, well, you can copy this. Prasad, you there?
Yes, I'm here.
Okay, could you please copy this link?
Yeah, definitely.
Okay, if you have never, just go through it. Okay, you will learn how decryption works. You will learn how SSL works. Okay, you will know how the certificate authority works. Okay, so this guy like Shaktiman, so he was my trainer when I was in Palo Alto Tech. So like he has very good knowledge, and that is
Can you share my WhatsApp, please?
Yeah, I'll share it.
Okay,
yeah, I'll share it on the WhatsApp above. Yeah, so before we disconnect, any question from you guys?
No.
So tomorrow, SSL and IPsec, and I believe we will be done with our basics. Okay, and from next week onwards, we will start the Palo Alto. Okay.
Sure. Okay.
Yeah. Thank you so much for your time, and have a nice day.
Thank you.
To have a nice day. Bye bye.
Yeah. Bye bye.